So after the exams, I'm going to switch on the new lesson in chemistry. Today I'm going to complete the next inorganic content, the seventh chapter, P block elements. In this P block elements, so first of all you understand how the blocks of the elements have been divided. So depending upon the electron configuration, the elements have been classified on the basis of the electronic configuration in which do the orbitals fall. We know that orbitals sp.df. If you write the electronic configuration, the last electron which jumps in the s orbital, those are called as an s black elements. And as according to the atomic number, if you write electronic configuration which fall in the p, they are called p black elements, and d black, and the f black elements. So we have been converted all the elements into the 4 blacks. So in the first year you already learnt p black elements, but only the few. So totally how many p black elements are there? So we know that the groups and the rows, 18 groups are there. The vertical columns are called groups and the horizontal lines are called rows. In 18 groups, in that 18 groups, the p black elements start from 13 to 18. 13 to 18. So we have to learn that all the p black elements. First of all, you know what are the different type of the elements which comes under that, the p black elements. As according to the period table, we should have the picture of the period table and the p black elements. So you know that the period table, how that the period table it forms, and how the elements are going to be classified. So the p black elements, just I give an introduction, then I will go in detail. We are not going to learn 13 group and the 14 group, but we are going to learn from the 15th group in second year. So we have to know that the p black elements from the 15th group. So how that what are the different areas you are going to cover in this p black elements that I come to know you. So here in this one, the first of all, the different type of the p black elements, how that one they obtain and how do they present in the 15th group elements: nitrogen, phosphorus, arsenic, antimony, and bismuth. Nitrogen, phosphorus, arsenic, antimony, and bismuth. So first of all, we should go where do they present. First is how do you understand these 15 group elements in the order wise. First is the nitrogen, then the phosphorus, nitrogen, phosphorus, then arsenic, antimony, and bismuth. So that we can learn in the different form: nitrogen, phosphorus, arsenic, antimony, and bismuth. So NPAS, SB, and BI. So you can learn in the different way also: Nepal, Pakistan, Australia, Sab Bimar hai. This is our earlier one. You can learn in that on that view also. So first you go for where do we obtain these, the metals, the 15 group elements. 15 group elements, first is the nitrogen. Where do we obtain nitrogen? Nitrogen is present in atmosphere. 73% to 80%, 73 to 77 or 78% up to 80% depending upon the environment, then we obtain nitrogen. So it is also present in that's nitrogen is in the one form. It is also present in the form of salts. That's about the Chile saltpetre. So the salt which is obtained in that, it's called Chile saltpetre, and also Indian saltpetre. The difference between the Indian saltpetre and the Chile saltpetre is, one is a sodium nitrate, that is Chile saltpetre. If it is potassium nitrate, that is Indian saltpeter. So that is about the nitrogen, two salts. It's also present in atmosphere, and it's also present in the form of the salts, chili salt and the Indian saltpeter, chili saltpeter and Indian saltpeter. Then the phosphorus, it is in the form of phosphate only, but it is a different form is there, apatite. There are the different types of the halogen is going to be mixed with it. If it is in chlorine is there, chloroapatite. If the fluorine is there, fluoroapatite. Like that, the fluoroapatite, chloroapatite will come. Just I'm briefing, then I will explain in detail when we go through that the scripts. So what are the things you are going to learn that I explained now? That's all. Then we come to that one when we go for the different types of the elements in the periodic table. So the first one is in the nitrogen. Nitrogen has got the electronic configuration, so atomic number first 7, then 15, then 33, 51, 83, and these are the continuously towards 15 group elements. So when you write that one, you can come to know that one, the different types of the properties. That we called as an traits in physical and chemical properties of p-block elements. Traits in physical and chemical properties of the elements. And before that going the trains, rest of the elements after nitrogen and phosphorus, where do these arsenic, bismuth and antimony they would train? Arsenic, antimony and bismuth. Bismuth is one of that. It is also one of the compound along with the sulfur. All called as sulfide compounds. Along with sulfur, all these arsenic and antimony and bismuth along with the sulfur only. So that's why we call it sulfur compounds. Sulfur combined compounds. So this is about the thing. Then we come to that. First of all, where does it obtain? Nitrogen is obtained in nature and also in form of the salts, different salts, chili saltpeter and then Indian saltpeter. Then about the phosphorus is in the form of the phosphate. That is apatite, fluoroapatite, chloroapatite, the hydroxyapatite, different things are there. Then after this one, trains. It trains in the sense, just we consider all the properties of that the elements. Atomic number, electronic configuration, atomic mass, density, electronegativity, ionic radius, atomic radius, covalent radius, electronegativity, then about the melting point, boiling point. Then all these properties are going to be studied in detail. Then how do we study these p-block elements? It's a very important chapter for the examination view. As we know that one, just to down the group, just to go for that down the group, what are the different properties are going to be changed, which are going to be increased and which are going to be decreased. Just to put a line, whether it's going to increase, just to put increase, then it's down the group only. First down the group, whether it increases or decreases. Then I am going to tell you most of all are going to be increased, only a few are going to be decreased, so that you can go for that. For example, atomic radii and ionic radii, then ionization enthalpy and then electronegativity. These are going to be decreased. In the few only they decrease, then the other properties are going to be increased, so that we can learn in detail. Okay, then the next after this one, the covalent characters also there. How that the covalent characters, whether that first we are going to study about the nitrogen, how does it reacts with hydrogen, how does it reacts with oxygen, and how does it forms that the covalent reactivity, the different type of the different aspects of the things are there. First nitrogen, then after that the different compounds, uses of nitrogen, and how do you prepare nitrogen, that's also very important. So the preparation of nitrogen, before that one, the preparation, we have to go for that. There is a special property of the nitrogen is there. There is an anomalous behavior of nitrogen. It behaves differently rather than the other elements of the same group, 50 group elements. So what are the different things are there? So here's the first one is it's a very important point on the view of examination. it has a small size element. So the small size, then it has high electronegativity, it has high ionization enthalpy, and a non-availability of d orbitals. When you compare that to the 15 group elements, d orbitals are not present in nitrogen. So it's small size, high electronegativity, high ionization enthalpy, and non-availability of d orbitals. In this, we have to notice this point, dear students. The first one is the small size. As it goes, that one, it starts from the atomic number 7. Then all the atomic numbers are going to be increased. Then the size is very small. Then high electronegativity. As we told that one trains of the physical and chemical properties, electronegativity is very high first. Then it's going to be decreased down the group. If you're asked above the group, just the reverse of the down the group. Then high initial enthalpy. So these are both are the two characters are going to decrease. Then non-availability of d orbitals. This question is going to repeat in the different type of the reason questions. I think that's about why questions. Why? In this reason, these 4 points are very important. Due to small size, due to high electronegativity, due to high ionization enthalpy, and again non-availability of d orbitals. Formation of next, how does that it form the different character of the nitrogen? This is very important, just I repeat. Formation of p pi and p pi orbital with carbon and oxygen. Nitrogen forms p pi and p pi orbitals. We know that the different types of the orbitals form the shape of the orbital. Here it is, the reason of that one, atomic orbitals are so large, they cannot overlap. In the nitrogen, they cannot overlap, and it is a diatomic molecule. That's why it forms what? P pi and p pi orbital. No other element can form the p pi orbital. All are going to form the p pi and d pi orbitals. So here's the next one is a higher bond enthalpy. The higher bond enthalpy forms that one, phosphorus single bond, arsenic single bond, antimony single bond, but nitrogen is triple bonded. That is due to that the one of the thing. And nitrogen has a very low reactivity. That's called as an inert. Why it is an inert? Because of that inability to form d pi and p pi orbitals. We know that's an absence of d orbitals. So I told that the 4 points, that's very important. How does it go for that? The different type of the contents. Then the explanation will go for that. Then the nitrogen. Now the preparation of nitrogen is there. Just I'm briefing. Then you go in detail with the scripts. Again, often later I'm telling this one. This is the 80 up to 73 to 75%. 73 to 74% is more nitrogen is present in atmosphere, and it is weight of 80%. So it's present in the different nitrate salts, and it's also present in the that salts and also in the atmosphere. And it is very essential for protein synthesis. Whatever the protein you take, the protein is made up of this nitrogen element. It has to contain nitrogen. Without nitrogen, the protein cannot be formed. Whatever the protein content is, if you take the constituents of the protein molecules, carbon, hydrogen, oxygen, nitrogen, that should be there. Nitrogen should be there. Amino groups, that should be there. That's about the what? The protein compounds in as well as plants and animals. If there is no nitrogen is present, and there is no formation of the protein synthesis. As it does not form the protein synthesis, we do not survive. So it is also helpful for living beings, both the plants and animals. Plants absorb the nitrogen, atmospheric nitrogen, and they also absorb the nitrogen which is present in the molecular form by the root nodules. Then, as we know that when it prepares the food, the plants prepare the food, then we get the food. So this is also the how it is nitrogen is going to help. So dear student, just to know that one application, how it is an applied nitrogen, we are going to utilize it. Simply reading it is not the thing. Got it? So don't go for that simply reading. You just mention that point. It should be very clear. clear aspect of that. As you know the clear aspect, then you can write in detail. Otherwise, you'll make the short points. That's why I'm telling. Don't prepare for the examination. Prepare well for that complete knowledge. As the marks are assigned on the different chapters, you should go in detail. Then come to the preparation. Just I tell the preparation only. Just I'm not going to explain everything. That nitrogen can prepare by using different salts for systems. And before that one, we can go the fractional distillation. As we know that the fractional distillation, the commercial method of that nitrogen is there. The fractional distillation method. The fractional distillation method, you know, already in the extraction of petroleum. In fractional distillation, in the sense, the heating of the given obtaining the compound and separating the constituents depending upon the boiling point. The constituents are going to be separated depending upon their boiling point. Here it is also nitrogen and oxygen also. The gas, the atmospheric gas is collected. The different form of the gas is collected, and we are going to make it conducting by under fractional distillation. We are going to separate the nitrogen and oxygen. So nitrogen having the percentage of that the boiling point is 77.3 Kelvin, and the same wise oxygen is oxygen is 90.04 degree Kelvin. So depending upon the boiling point it goes. Then another methods also there by using ammonium chloride and by using ammonium chromate also. Ammonium dichromate, NH4 twice Cr2O7. The chemical compounds are very important. If you know the chemicals, you can write the examples, you can write the equations. When you are learning, write the equations and learn. Don't get mugging. Don't get it by hitting. Just write the equations. Then you can come to know the equation, the formula, and it is easy also. So then after that one, thermal decomposition of that ammonium nitrate and ammonium chromate, and thermal decomposition of azide compounds. That's about barium azide or nitrogen sodium azide Na3, barium azide. Azide means N3 compounds. Barium azide and nitrogen azide, these are good. Then the properties of dinitrogen. These are very important questions for 1 marks and 2 marks. The preparation is there, that I will come in that the detailed view. As I conclude, what are the contents till of the first one, nitrogen, and some content briefly. It is a colorless, odorless, and tasteless, and non-toxic gas. We cannot see the nitrogen which is present in the atmosphere. Can we see it? So it isn't colorless. It is odorless, no smell at all of that nitrogen. So if you see that if it is have the color, we can identify easily. If it has odor, then we can observe the smell of the nitrogen. So colorless, odorless, and tasteless, no any other, and no toxic, non-toxic. If it is toxic, when we inhale, we are going to get diseases. We are going to become suffocated. So different types of the respiratory disorders would affect us. That it forms the two isotopes, N14 and N15. Low soluble in water, solubility is poor in water, and it is an inert atmosphere. It is also used to create an inert atmosphere, and it reacts with the different types of metals and non-metals. It forms nitrites, different nitrites. So that we are going to study. Then after this one, uses. As we know that how does it use? What are the different uses? Again, it's a very examination view of examination oriented point. That's ammonia by Haber's process. Ammonia NH3, it is prepared by using Haber's process, both the nitrogen and hydrogen. So nitrogen is contained in the ratio of 3:1, that you are going to get to 3 mark questions. And it is also used to create inert atmosphere in industrial chemistry, calcium cyanide. So in order to, when you are extracting the metals, in order to create an inert atmosphere, we use nitrogen because it's an inert inertness, the inertness of the nitrogen. Then this one more thing is that it is used for cryosurgery. Cryo in the sense cold. In order, by creating the cold atmosphere, the surgery is going to be conducted. In order to create the cold atmosphere, nitrogen is used. That's called in cryosurgery use. Then after that, the compounds of compound, very important compound with hydrogen, ammonia. Ammonia is prepared by using nitrogen by Haber's process. Before that one, how do we get ammonia? What is an ammonia? Ammonia is also a ammonical silver. That's also one of the waste. Ammonium salt is there, ammonium phosphate is there, then urea is there. So NH2CO NH2, that is urea. It's going to be one of the content. It is also first come to know that one, when the organic compounds cannot be synthesized by in the lab, under the lab means, that is denied by this preparing of urea. So urea can be prepared in laboratory. That is an organic compound. So organic chemistry has been converted into a big branch by knowing that one, the compound of ammonia, and then it is with the carbon and oxygen, it forms an urea. So by urea we know that one ammonia is present. When that urea is hydrated, when it is react with water, it forms nitrogen. Again in small scale, again ammonium chloride. We obtain ammonia. That's about again the salts only. Then after this one, we are going to learn the different the process of the synthesis of ammonia. That's by Haber process I told. Synthesis of ammonia by Haber process. Haber is that one. He took the components of the two, one nitrogen and hydrogen, mixed in the proportion of 3:1. Nitrogen is 1 and then hydrogen is 3. 1:3 ratio, and they combined it. He combined both the gases by the compression, again by applying the reactant, catalyst, and about the temperature and pressure conditions. Then we are obtaining the liquid ammonia. There in this one, they ask that one, the conditions which are applied in the preparation of ammonia or synthesis of ammonia by Haber's process. First one is the Lee-Chatelier principle, by applying the Lee-Chatelier principle. It is a Lee-Chatelier principle where what is meant by Lee-Chatelier principle? Please go through this one. Lee-Chatelier in the sense, it is a law of equilibrium. It is a law of equilibrium. What does that law tells about? So we know that when the two sides are there, one side is the reactant, another is the products. The reactants react together, gives rise to products. When the reactants react together, that's an equilibrium. Should be equilibrium. When it is an equilibrium. When we apply the external constraints on the reactants, on the equilibrium, it's in the sense of forward reaction and backward reaction. When an external constant is applied on the equilibrium, like temperature, pressure, catalyst, any other things, what happens? That equilibrium nullifies the effect of the external constraints. It nullifies the effect of the external constraints in an equilibrium system. That is called as which law? That's Lee-Chatelier principle. That is going to be applied in the ammonia by Haber's process. Then again the pressure, high pressure is applied, that is 200 atmospheric pressure is to be applied, and temperature is 700 Kelvin. So then we have to use it. That's about the synthesis of ammonia. Then after this one, after I make it concluding that the brief introduction, that you are going to learn many things. The different types of the compounds of oxides and nitrogen. When we go through that, the oxides and the nitrogen, the properties of ammonia should be learnt and uses of ammonia should be learnt. Again, the structure of ammonia, you are going to learn that in detail. Then oxides, it forms different oxides depending upon their oxidation state. Nitrogen shows variable oxidation state. That's depending upon the variable oxidation state, it forms different types of oxides when it is nitrogen is treated with. So with one oxidation state, it forms nitrous oxide, N2O, First one is N2O. N2O. Again NO. You can take NO first or N2O second. So NO and N2O, or N2O plus oxidation. If it is take N2O, that's clear, because one oxidation state, two oxidation, 3 and 4 continuously it comes till 4. It is easy to remember. NO, it is nitric oxide. See, nitrous oxide, nitric oxide. N2O is nitrous oxide, NO is nitric oxide. And N2O3 is dinitrogen trioxide. Dinitrogen trioxide. And NO2, nitrogen dioxide. And N2O4, nitrogen tetroxide. Then N2O5, nitrogen pentoxide. As it is 4, then it becomes the 4 oxidation states for different variable oxidation state. So these are the things you are going to learn in the next coming the session. Then after completing this one, you are going to learn the different aspects. The p Blockage element is very important aspect. Just please go through this one. I think I conclude this introduction. Then we start in detail the p block elements. Welcome you. Thank you.